We have 4 objectives in this chapter. First, recognize equivalent inequality. Solve inequalities by using algebraic method and graphical method. Graph solution to absolute function. And the last one is application. Let a and b are real numbers. We say that a is greater than b, and we can write this inequality form. A greater than b. Look at this symbol. If a greater than b, so for this symbol, the mouth is open. If we say that a is less than b, then we can write this inequality form. Clearly, a less than b means b greater than a, and vice versa. If we write this form, meaning that a is less than or equal to b. For elementary operation on inequality, consider any real numbers x, y, a, b given x greater than y and a greater than 0 positive value and b is negative value. We have these 4 results. Look at the addition. We say that x just 5 and the y is 4 and the a 1, b negative 1. We test for the addition. 5 plus 1 is greater than y is 4. 4 plus 1 and x is 5 plus b, where the b is negative value, greater than y is 4 plus b. So 4 greater than 3 is true. And one more, you can take the third. Ax greater than ay, where the a is 1, x is 5, greater than a is 1, y is 4. So it's true. But then bx less than by, b is negative 1, x is 5, b is negative 1, y is 4. Some important results by using analytical method. A and b are real numbers. The multiplication of a and b is positive value if and only if a and b are positive value, or a is negative value and b also is negative value. For the second statement, the multiplication of a and b is negative value if and only if a is positive value but b is negative value, or a is negative value and b is positive value. Linear inequalities. A linear inequality in one variable can be written in one of the following forms. We have 4 types of this inequality: less than, greater than, less than or equal, and greater than or equal. And why we say this is a linear inequality? Because the order of x is 1, where x is a variable, a is a non-zero real number, and b is a real number. Linear inequalities are solved by using properties of inequality. Look at the example. Solve the following inequalities. For a, 5x minus 4 less than or equal to 6. We move the negative 4 to right side, would be plus 4. And in order to get the x, so we divided by 5. And the answer can be written as from negative infinity to positive 2. And for the b, negative 5 less than or equal to 2x plus 1 less than or equal to 3. So in order to eliminate the positive 1, so b minus 1. For the left side, minus 1, and the right side also minus 1. So here, we just have 2x. And to get the x, so the whole inequality divided by 2. So we have negative 3 and 1. So we can conclude our answer. The x is between negative 3 and 1. Quadratic inequalities. A quadratic inequality in one variable is an inequality that can be written in the forms. We have 4 types as well. And why we say this is a quadratic? Because the order of x is 2 and the leading coefficient is not equal to 0, where x is a variable, a, b, and c are real numbers. Quadratic inequality can be solved by using algebraic method and graphical method. For algebraic method, we have 5 steps. First, use the properties of inequalities to obtain a 0 on one side of the inequality. Second, factorize, if possible, the quadratic expression on the left-hand side. Third, let all the factors equal to 0 in order to obtain critical values. Step 4. Draw the number line based on step 3. Last step, determine the sign for each interval. For graphical method, the graph of the quadratic expression y equal to ax squared plus by plus c is sketched, and the points where the graph cuts the x-axis, say P and Q, they are x-intercepts. So for the leading coefficient is positive, we have a U shape, and for the leading coefficient is negative, we have an N shape. And if y greater than 0, so we should select the above side. Here is above side. So the area here is less than P, and the area here is greater than Q. And for y less than 0, we select the bottom area. So the area here is between P and Q. So this is the answer. Same for the leading coefficient is negative. Y greater than 0, we select above side. So the required interval is between P and Q. If y less than 0, So we select the bottom area. So the area here is less than P, and the area here is greater than Q. The example: find the solution set of inequalities x squared greater than x plus 2. Step 1. Rearrange the inequality. You move the x plus 2 to left side. So we have quadratic inequality. And you factorize. Make sure the x is positive value. The leading coefficient is positive value. And third step, find the critical values. Let the first two factors equal to 0. And we have critical values are -1 and +2. Step 4. Draw number line. For this x-axis, -1 is here, and x equal to 2 is here. And because the inequality sign is greater than 0, so for the first factor, the line towards right. Same for the second factor, towards right. And the sign is not equal. So meaning that we shouldn't include -1 and 2 as well. And because towards right, we fill by positive. Because the interval here, for this factor, will produce positive value. And same for second factor. So after we fill out the plus minus sign, look at this step 2. The first factor multiply second factor. So must greater than 0, meaning that we should select the positive region. Positive, positive, positive. Positive, negative, negative. The multiplication. Negative multiply negative, positive. So this is a required region. You can see the sign here actually is produced by the multiplication of these two factors. And for this region, x greater than 2. And for this region, x less than -1. For rational function, you have recognized what is the rational function in chapter 1. For example, fx over gx, where fx and gx are polynomial of x. To solve the rational inequality, we have two methods. First, we call analytical method, and the second, getting rid of the denominator. Look at the first method. If given rational function greater than 0, based on our definition, fx is positive value and gx also is positive value because the greater than 0. So the whole thing is positive value. Or we can say the fx is negative and the gx also is negative because negative divided by negative is positive. For the second method, we multiply both sides by gx function square. For example, this is a rational function. We know the denominator function is a gx function. So we square and we multiply this gx square at both sides. And we solve the inequality. And you can see here, already get rid of denominator, the gx function, and we form polynomial gx expand with fx. This example, find the solution set of the inequality x plus 2 greater than 30 over x plus 1. Look at this term. This is a rational function. So we only have two methods to solve. Either first method or second method. Not cross multiply. I repeat, not cross multiply. So first, you have identified this term is rational function. So you should know x cannot equal to -1. And we move the whole thing to left side so that our right side is equal to 0. Refer to our first method. It's not cross multiply. And we group this all thing into one fraction. So for the x plus 2, we multiply the x plus 1. For example, we have x multiply the x plus 1 over x plus 1. And same for the 2, the second term. And for these three fractions, they have same denominator, so we can group it, become one fraction. And from the numerator, we can simplify. And we have x squared plus 3x minus 28, and we factorize. After we factorize, so the rational function in factor form, so able us to get the critical values. So since we have three factors, so meaning that we have three critical values: -7, -1, and 4. And again, refer the inequality sign. The sign is greater than 0, so the line should towards right. And above the line, we fill out by positive. And the rest, we fill out by negative. And we follow this rational function. The first factor, look at the -7. The first line represents the first factor. And I write down, this one is the first factor. And -1 represent, we say this x minus 2 minus 4 is the second factor, and we say the x plus 1 is the third factor. So this one is the first factor, and this one is the third factor, and for the second factor. So just follow. You can see the result from the first factor is positive. So positive multiply positive is positive, divided by positive is positive. And look at the second interval here. Positive multiply negative is negative. Negative divided by positive is negative. So look at this inequality, the whole thing. Our output should be positive value. So we select the positive region. So this is the answer. For absolute value inequality, the statement modulus of x, or we say absolute value function of x less than 3, can be interpreted to mean that the distance between x and the origin is less than 3. So x must lie between -3 and 3 on the real number line. So here, The region here represent the absolute value here. In other words, the modulus of x less than 3, same as x is between -3 and 3. Same for if modulus of x less than or equal to 3. So refer to this real number line, because here include 3. So here is include. So what can you read from this number line? The interval here is between -3 and 3, included -3 and 3. And how about the x greater than 3? So refer to this number line, meaning that the distance between the x and the origin should greater than 3. The distance between the x, you can see here is a required x value, and the origin should greater than 3. So should start from here. And here also 3 greater than 3 units. So you can see the first region is greater than 3 and the second region is less than -3. And how about modulus of x greater or equal to 3? So same as the previous one, but included -3 and +3. Look at this example. Find the solution set of the inequality modulus of 2x minus 3 less than 5. And what do you understand about this inequality? From number line, you know less than 5 meaning that here is the region, because less than 5 units from origin. Even this side or this side, 5 units, less than 5 units from origin. So here is the interval, required interval. So what do you understand about for the first interval? The value here is less than 5. So less than 5. And here is greater than -5. So 2x minus 3 greater than -5. So we back to linear inequality, where our first example. So we solve the linear inequality, and from the linear inequality you can draw another line and you conclude your answer. And same for this side, x greater than -1. So this is a number line represent the x greater than -1, because the region here is greater than -1. And you can conclude your answer, x greater than -1. After that, look at the next page. You combine your result from the previous page. For x, this graph, this is a combination of your previous result. Look at the first line. The first line is x less than 4. And for the second line, the x greater than -1. Remember, in the combination of number line, there is no plus minus sign. There is no plus minus sign in the combination number line, where you should select the intersection or the union region. look at our question. Our original question is modulus of 2x minus 3 less than 5. The inequality sign here is less than, so we select the intersection area. So we'll be here. Then this is our answer. If the inequality sign here is greater than 0, so we select union region. Look at this example. This is third objective. Graph solution to absolute function. Sketch on the same coordinate axis the graph of y equal to modulus function of 1 plus 3x and y equal to 6x. And then solve the inequality modulus of 1 plus 3x less than 6x. Sketch the modulus function and linear function. You can, based on the first chapter, first section method, you construct table, then you sketch. And you know that the modulus function will produce V shape. So you can look at this. For example, you know the shape, just for example, the shape of the modulus function is V. And for another way, look at this working. For this modulus function, 1 plus 3x, we can determine the minimum value of y equal to 0 when y equal to 0 is x intersection will be here, the minimum point. So where we just let 1 plus 3x equal to 0 because the y equal to 0, x intersect, then we get x equal to negative 1 over 3. So will be here. Let's say here is negative 1 over 3. So your line start from this point and we form a V. And what is this y intersection? We let x equal to 0. For y intercept, let x equal to 0, then we substitute 0 into here and y will equal to 1. So here. And we form modulus function curve. And you should label. Okay, you can label the equation name. So from the previous page, we have information, the minimum point and also the y-intercept. So we're able to sketch the graph out or based on your table. So this is a absolute function graph and the linear line. And make sure you label the x, y axis and also the equation name for each function. So for the original function, modulus of 1 plus 3x is V. And for this line, you see, this line has negative slope. So the equation is negative 3x minus 1. And for this line, the gradient is positive. So the line equation is y equal to 3x plus 1, represent this line. And based on this graph, you can see there is only one intersection point, is here. So you can solve it simultaneously based on the first chapter, how we get the points of intersection. So this point is formed by this line, linear equation, and this linear equation, y equal to 3x plus 1. So you solve them. And lastly, we have x equal to 1/3. So this is a x coordinate 1/3. So this is a complete graph. For the second question, the question asks to get the inequality for modulus function of 1 plus 3x. Is a modulus function less than 6x. So we can name this modulus function as the first function and linear function as the second function. So look at these points of intersection. We just only have one point of intersection, so meaning that we have two intervals. So the first interval is before this point of intersection and after. We say before 1/3 is the first region, and after 1/3 is second region. So the question required the first function less than second function. So this line is first function. This line is first function. And this line start from this point, 1/3. Look at the first interval. Look at the first interval. So this line is second function. You see, the first function is higher than second function. So, meaning that the first interval is not the required region, because our question is the first function less than second function. So look at the second region. This line is linear. You can see linear is the second function. And this line is first function. We say the second region is required region because we satisfy the inequality. Look at this. The first function less than second function. The first function is here. Is lower than second function. You can extend your line. So the answer is x greater than 1/3. So we can conclude our answer. Write our answer in solution set form. Here are some of the verbal statements to solve the application question. Look at the last example. An overnight delivery service will not accept any package whose combined length and minimum girth. Look at the first important information. The combined length and minimum girth. And what is the meaning by the girth? It's parameter of a cross section. Let's say 132 inches. You are sending a rectangular package that has square cross section. The length of the package is 68 inches. what is the maximum width of the sides of its square cross section. You can highlight some of the given information. For example, square cross section, and the length of the package is 68 inches. From the question, there is no model is given, so you have to create a model to solve a problem. Look at the verbal model. The length plus curve not exceed 132 inches, meaning that less than or equal to 132 inches. And you can introduce the variable that you may use. For example, the width of the side is x, and the length is given 68. You can refer to this figure. The length of this package is 68 inches, and the cross section is a square. So since you have identified your width of the side is x, so the parameter of this cross section is 4x. And from this verbal model, we transform into mathematical inequality. So the length is 68 plus the curve 4x less than or equal to 132, and we solve. So we have x should less than or equal to 16, and you can conclude your answer. The width of each side of the package must be less than or equal to 16 inches.